electricity, we come across the terms like E.M.F, that is electromotive force, potential difference, and internal resistance. Now when we say E.M.F or electromotive force, it is the potential difference between the two terminals of the battery when the circuit is open. The E.M.F of battery can be measured by using instruments like potentiometer. Potentiometer can also even be used to find the internal resistance also. Now what is internal resistance? When we say we have two electrodes of battery, and when we have a circuit outside this, the electrons, they may be moving in this direction. These wires, they are conductors, and we know in conductors, metallic conductors, the charge carriers, they are electrons. So electrons, they are pushed in this direction, they go over here, and we know battery is a source of energy, it is not a source of charges. If it pushes the electron in this direction, at the same instant it wants an electron back into its positive terminal. So we have two electrodes. There is also a motion of ions between these two electrodes, and we have electrolyte solutions or electrolytes through which these ions they move. When these ions move through electrolyte, they come across some resistance. This resistance offered within the battery by electrolytes, etc., that is called internal resistance. That is represented by a small r, and this is sign. Over here we have a 10-volt battery. Once again, the internal resistance is given as 1 ohm, and there is also 8 ohm resistance in the circuit also. Now we have to find out what is the E.M.F and potential difference between the terminals of the battery. When we say this is 20 volt, this is the E.M.F of the battery. When the current starts flowing, then the E.M.F may not be equal to the potential difference. Potential difference can be higher or lower than the E.M.F of the battery depending upon whether the battery is getting charged or whether the battery is getting discharged. Like in this case, if you see these two batteries, this is 10 volt, this is 20 volt battery, they have internal resistance 1 ohm and 1 ohm. So because this terminal is positive, so this will try to push the conventional current in this direction, and this will try to push the conventional current in this direction. Because this battery is stronger as compared to this battery, as a result we can say the current will be flowing in this direction. So the current will be flowing in this direction. When we say 20 volt, it is the E.M.F of this battery. When we say 10 volt, it is the E.M.F of the battery. And now we intend to find what is the potential difference between the two terminals of the battery. So for that, what we do is we take out this internal resistance and we fix it over here. Let's say we fix it over here, 1 ohm resistance. This is 10 volt battery, and let's say we have put it in a box. We say this is C and we say this is D. So whatsoever is this within the box, this represents the battery. Whether the internal resistance is this way inside between these two terminals, or we have put it over here and now we consider this box, this one and the same thing. The same thing goes for this 20 volt battery also. We say this is 20 volt is the E.M.F. You can draw resistance over here also, or resistance over here also, internal resistance, that doesn't matter. So this is also 1 ohm, and we say this is B, and we put it in a box, imaginary box, and now whatsoever is the potential difference between A and B, that is the potential difference between the terminals, between the two terminals of the battery. Same thing, whatsoever the potential difference between C and D, that is the potential difference between the two terminals of these battery when the current is flowing in the circuit. When we slide this battery over this, so their polarity will be something like this. So this is 20 volt, and this will come over here. This is 10 volt, and resistance in the circuit is 8 plus 1 plus 1. That is, all of the resistances, they are in series. So that makes a 10 ohm resistor. So 20 polarity is reversed. They are not reinforcing each other. They are working against each other. So this is equivalent to 20 minus 10. That is a 10 volt battery, and the resistance is, that is 10 ohm. So using V is equal to IR, using Ohm's law, so V is 10, I into R, so I comes out to be 1 ampere. So 1 ampere current will be flowing in this direction. Once we know what is the current which is flowing in this direction and what is the current shall be flowing in this, now we can easily find what is the potential difference across C and D. We know conventional current or positive current flows from a higher electric potential to lower electric potential. So when the current comes over here across 1 ohm resistor, there is a drop. There is drop of what is, because conventional current is flowing in this direction, it means C, and let's call this as point as X. When we talk about C and X, C is here, X is here. conventional current is going from here to here, it means this is at a higher potential, this is lower potential, and the potential difference between the points C and X is once again V is equal to IR, that is I is what? I is, we have calculated, I we have found, that is 1 into internal resistance is 1, so this is 1 volt. So the potential difference between C and X, and over here say we say D, 10 volt, we can write it over here, this is 1 volt. And now when we go from X to D, so we have gone from higher potential to lower potential, that is there is once again loss of 10 volt, so there is a loss of 10 volt. So this is 10 volt plus 1 volt, the potential difference between C and D is going to be 1 plus 10, that is 11 volt. The potential difference across the terminals of the battery is now more than the E.M.F of the battery, so this battery is getting charged. Whereas if we consider this battery, the current is flowing in this direction, and when we go from B to, let's say, Y, if we go from B to Y, it is going, conventional current is going in this direction, so it means that is B is at a higher potential as compared to Y, and the potential drop across B and Y, V is equal to IR, current is 1 ampere, R is 1, so once again this is 1 volt is a drop across this, and over here we say it is going from negative to positive, that is there is a benefit of, there is a jump of 20 volt. If we go from Y to, let's say, when we go from Y to A, there is a jump of 20 volt. This is a drop, this is 20 volt, this is a jump. So overall between B and A, if we say, so there is 20 minus 1, this is kind of a gain, this is kind of a loss, 20 minus 1, that is 19 volt. This is the potential difference across BA, that is, so 19 volt is the potential difference between the two terminals of battery, that is B and A. This battery is getting discharged, the potential difference is lesser than the E.M.F of the battery.